Hi everyone. So we're back again. So another day. It's another day of class, and I hope we are doing great. Hope we uh, had a wonderful time. So confirm if you can hear me. Let me see if you can hear me. Have to go online too. Okay, so I'm live too. So good evening. All right, good evening. So great, you guys can hear me. So today we'll start. I want to quickly cover up today's class so that I can finish what we have here. So let's just run. Let's run. I want to quickly finish what I have here on the charts. So we'll continue with data structure. Last time, yesterday, we began with uh, list. We talked about list. So I said I want to talk about tuple. Before we go on, like we used to do, let's share the link on our platforms, social media platform, WhatsApp, Instagram, Facebook, LinkedIn, any platform that you are, and then tell your friends to come and learn with you. But that being said, let's move ahead. Welcome, Flora. Welcome, Francis. Welcome, Dorcas. Welcome, Evis. Susan, you're welcome. All of you are welcome. Now, where is Grace? I guess she's on her way. Or stuck in traffic. I guess so. So let's just move ahead. So we'll talk about a tuple. Now, a tuple, it's same as a list. It is a collection of data or values of the same type or different type. But we also said that, remember when I said that a list is changeable, you can change the item in a list, but in a tuple you cannot. So once it's created, the value cannot be changed. Tuples are useful when you want to represent a collection of items that should not be modified. So you don't want it to be changed. You don't want it to be modified. Grace, you're welcome. So, what are the examples of when you use tuples? For example, coordinates, x and y. You want to map a point. So these are things that you don't want to change. Once you create coordinates, you don't want to change them. Okay. So, yeah, maybe functions returning multiple values, data records. So these are things that you might want to use tuples for. So this is how we create an empty tuple. Same way, let me select a kernel so that I can correctly select it. Great. So same way we create a list in terms of to find the type, but this is different. Or a list uses square bracket, or tuple use parentheses. I guess this is parentheses, right? So once you run it, let's just create insert values into a tuple. So I've inserted a value inside the tuple by just this is a single value inside, and take it in your mind that everything that I said about assessing, slicing, everything stands. Okay. You can also declare. This is me declaring multiple. Let me make this a little bit bigger so that some persons can just see what I'm doing. So 2, 3, 4, 6, 90 declared it inside a tuple. So once you print it, it's still saying is a tuple. What if I want to just print the value? Let me print the value out. New example. So you can see the way it's coming out. It's coming out with its own, uh, you know, parentheses or the whole symbol, the symbol assigned to a tuple. So if it's a list, it comes out with a square. If it's a tuple, it comes out this way. So these are the easiest way you know them, you identify them. You can also declare a tuple without putting the value, without putting the open and close um, parentheses, because once you say 2, 3, it's Python takes this also. Once you separate different values by comma and you leave it like that without even putting them inside a a brace, or Python sees it as a tuple. So just for you to know. So if you do, maybe you mistakenly want to declare a value and you say that my top is equals to, maybe my value is equals to 10, and mistakenly you put a comma in it, Python will take it as a tuple. So be careful with all of this. These are very, very semantic error stuff that might occur. I'll be talking about things like semantic errors. I know somebody, I expect somebody to go and research what I mean by semantic error. So we have syntax error, semantic error, which also some people call it logical error. So it's good you have those ideas. It could be interview questions. I can ask you, what is the concept about? What's the concept behind semantic error? What is the concept behind logical error? If you cannot explain it, it means you don't know the terms. So are you a good coder? So you see, once we do this, print it out, we get a tuple. So a tuple can also have multiple data set, like we said. So let's start working inside. So I've created a tuple like this, zero. Um, okay, this is a tuple I've created. I want to find what is the index two. See, I can access it 0, 1, 2. I can access it. I can also slice a tuple. We've talked about this on the list. But what if I want to change the value in a tuple? So I want to say that my top, that's 3 is equals to 10. So I want to change the value that I have here. 0, 1, 2, 3, 5. I want to change 5 to 10. Let me just print rather than going on the top. Let me just print it back. Great. So I want to change what I have here. 0, 1, 2, 3, 5 to 10. If I do this, I will get an error. You see? An error. A tuple does not support item assignment. Meaning you cannot change what you have in a tuple. So that is basically a tuple. You can find the index of an item. You can count. And we already know our short code. Okay, let's see. We can also do the length of a tuple. Basically, everything we did in list. Okay, but I want to show you that there's a shortcut the way we did the list too. If I just type the name of the tuple and put a dot, it will still show me. Those of you who are using VS Code and notebook and all of that, so it will still show me the only two thing I can do with a tuple is to find the count of a value and find the index of the value. I cannot say anything like append. There's no append, there's no extend, there's no sort, there's nothing in it. It stays the way it is. It's just two things you can do. Count and index, finish. That's the only thing you can do. Okay? So let's go ahead because I'm in a hurry tonight. I want to finish this thing because I want to finish set two. So it's possible we can have a list inside. Let me put a comment here. Just a minute. Okay, so please confirm if you can still hear me. I have to work on my mic. Okay, so where were we? Okay, we were here. So I want to know if you can still hear me. Just send emoji. No, those. Okay, guys. But you can still hear me. So we can go. So I want to write a comment. A list in a tuple. So you can see that we have a list inside a tuple where we have. Let me print this my top again. Print my top. So this is our list. Our list is inside a tuple. I think it's staying at index. This is 0, 1. What is the index of it? You can always find the index. There's no need counting. You can just do my top dot index. No, index. I never had counted, I would have gotten my answer. Then I'll just. But what if it is far? Can be counting? So it has index 7. Okay. So normally, if I want to change, let's say if I want to change the value of index 2 of the tuple, if I say my top, follow me guys, oh, my top index 2 is equal to, let's say 100, for example, is going to throw me an error. So I cannot change what I have in a tuple, but I can access what we have in a list. What I have in the list is my top index 7. So once I go to my top index 7, you could see that at that time, I'm having a list. This is a list. Okay, this is a list that I'm having now. Since I have a list, I can also go inside that list. All right, I can go inside that list because currently the in the 7 year it's showing me is coming from a tuple. It's coming from a tuple type my 7_4 to give me a list. You see, I'm bringing it out from a list. So what is telling me is that what I want to get from this index 7 in my tuple is a list. And guys, this is where the trick comes. Since it is a list, I can change the value because if I can access that list inside the tuple, I can change the value. So the first thing we want to do is that what if we want to get the okay, no, I want this. So what if we want to get this first item? What do we use? We use index 0, right, to get the first item. So that would be index 0. You can see I'm not using print because I'm using Jupyter Notebook. Or if you are using normal Python script, you have to put print. So sometimes, so to get the index, the first item is index 0. We get it. But because this is a list, we have the ability to change it. So I want to change what is there now to 20. I've changed it to 20. It works. So if I print my tuple, you see that it has changed 9 to 20. Okay, so what we are saying is that, or what I'm saying is that you cannot change this whole entire stuff inside the tuple. This entire list, you cannot just change it to a single value because it's appearing on the index of a tuple. But if you can filter it out and then you now index inside that list, you can change whatever is there because literally in a list you can change the value. That's the simple thing about it. Okay. So another stuff I want to talk about on a list, on the tuple rather, is unpacking. So we can declare our tuple like this that we have Edris Nosa 29 and put it into a value called details. Now we have declared our tuple. We can also do what we call unpack because sometimes I do this a lot. Unpack is that you can declare three. How many variables did you put in? How many values did you put in? 1, 2, 3, 4. So you can declare the total number of values you have in a tuple. See, we have 1, 2, 3. So we declared 3 variable in the same line. First name, last name, age. We say, okay, first name, last name, age. So what Python will do is that it will take this Idris, put it in first name. Take Nusa, put it in last name. Take age, put it in age. The 29, put it in age. That's what it's going to do. If, for example, I had other value like this, let's say I had 10, yeah, and I run it, it's going to throw me an error that, there are too many things to unpack because it's expecting 4 stuff and I gave it only 3. So I'll run this again. And mind you, this stuff I just ran is the same thing as this. It's the same thing as this is equal to details because remember it was in details because it was in details we set everything here inside details. So if I run this thing again, it's going to work. See, it's going to work. They are both the same thing. So I can print the item individually. So first name, that's unpacked first name, Idris into first name. Last name goes its own, and definitely age must go on its own. So if I do print, I say age, it's going to give me 20. Okay, my print is wrong. 29. Great. So another example I want to use to explain unpack. Let's say we have a tuple 1, 2, 3. And if we print that tuple out, you see that we have 1, 2, 3. So we can unpack it. SYZ is equals to our packed tuple. And once I print it, S is 1, Y is 2, Z is 3. Fantastic. So we can also have nested tuple. You can have a tuple inside a tuple. Obviously, a tuple inside a list. You cannot change it. Once you index inside, you cannot change it. So I've talked about this, how we can change the value inside a list. So this is where I do things like I don't need this, I don't need this, I don't need this, I don't need this. So yeah, so that's all we can do on that's all we can do on tuples. The next thing we go to is something called a set. Python has another data structure called a set. So a set is it's a collection of values too. Can collect values. It can also collect values on different data type. But one thing about sets is that even as much as it's collecting values, a set does not order the values. It does not order. They are not in order. Okay. So it means you can put values inside the set, and when you print it out, all the values can come out in different position. So you cannot index a set. And a set does not accept duplicates. It means that in a set, if you have two values appearing twice, only one will it will pick only one. If they are appearing 10 times, only one will stay in that set. Okay? So please mark all of these because you need them for your assessment. So how do we declare a set? Now, there's a trick to this, but I want to only show you. These curly braces that we have here is what we use to declare a set normally, but we also use it to declare a Python dictionary. The only difference where Python will know that this is a set and not a dictionary when you use this. For example, now we'll be doing empty set, empty tuple, empty list. There is nothing like an empty set. If you do something like this, even this is the symbol that we use to declare set. If you run it, Python will take it as a dictionary, not a set. So there's nothing like you are running an empty set. Okay. The best thing to do is to put a value inside. Okay. So how so we'll see the difference between a set and a dictionary anyway. The dictionary has what we call key and value, but a set does not have key and value. It's the same thing as it look like the same thing as a list. You open the curly brace and then you put apple, banana, cherry, and all of that. So this is a set that we have declared. If I run it now, you can see that it's saying it is a set because I've put single values inside. But when we use the same symbol, you're saying it's a dictionary. Python is not confusing itself. It's just telling you that if you want to declare a set, even if you can use this symbol to declare a dictionary, put the values inside. So what if I print it out? What did you take notice of? Can you see that when we set it, apple, banana, orange, and cherry, if it was then with a list, it will come out the way we arranged it. But in the set, it's coming out scattered. Banana is coming out. Imagine banana comes out first, cherry comes out second. Who born you? Okay, the apple is coming out third. Apple that was number one in the club, they brought it third. While anyways, it is where hmm, why I wanted to say something. I said why others are fruits in this place. Why all of them is fruits in this place? One of them stands to be a product. Okay, so when you hear things like apple, you think twice to ask yourself, what do you refer to? Are you referring to the fruits or you are referring to the product, which is very, very funny. Okay, that's the beauty of a brand. So we have another set. So this is another set we created. Apple, banana, orange, cherry. Apple is appearing twice. Orange is appearing twice again. But if I run it again, you see that it's scattered. Apple came out second. But then the next thing you see is that orange is coming out once. So those ones that appeared twice are coming out once. So that's the thing that set does not, all right, doesn't carry duplicates. But how do you add to a set? You can use add set. The same trick we used the other time, guys. You can do my var. Always this is a shortcut. My var two dots. So you can see what we can do to a set. So this one has a lot. Set has a lot. We can do add, we can do clear. All these are also what we call methods. These are also method of a set. clear, copy, difference, update, discard, intersection, update. Is this disjoint? Is this subset? Is this superset? Remove, pop, symmetric different updates, union, updates, and all of that. So it's just there. So these are the things that you can do on a set. But I'm going to talk about few because, like I said, we are running tonight. So we can add grep, add grep to our format set. Before when we use dot append, it will tell you that it will go and show at the last part. For where set, if you do add grep, the first shall be the last can be the first. Any way that suits it, anyway we enter in mind, and then you go drop them. So far you don't put them for where it's supposed there. What if I want to add more than one? So you can declare a tuple. This is a tuple that we have declared watermelon and lemon. We can use a tuple. We can update a set using a tuple. Okay. So we'll put our two dot updates, and then once we run it, the update still does something like you are doing extend. Okay. Because you cannot use add to add more than two elements. But if you want to add more than two, you put it in a tuple and then use the update method to do it. We can also find the length of a set. We can do something like this is just the common checking stuff. If a value is inside the set, print lemon in my value. You can do this in a list too. You can say you want to check if a value is in a list. This is it. So I can use this to run the code. I can say if lemon is in our set, print welcome on board. Board now. So you can see because it is in a set, it's telling us print welcome on board. So this is just some stuff you do. Okay, for example, a user wants to buy a goods, user wants to buy something, and you ask the user, what do you want to buy? The user says, I want to buy this. You quickly check the stock. If the what the user wants to buy is inside that stock, print available. If it's not available, display to the person and say out of stock. That's a simple logic with Python you can use to build those functionalities that you see on the website. It's simple like this, I be the way I'm saying it. It doesn't come in alphabetical. That set does not do anything. It comes the way it wants to come. So we can also copy. Please remember, I told you how to copy. You always copy. When you are copy like this. Don't say new var is equals to you remove this one. If you do it, anything you do to one will affect the other one. You can try it out and see. So we can remove. Remember, we can remove. We remove app from our set. We can pop. We pop any. Now, one thing about pop, because set does not have let me show you. Because set does not have a an index. Once you use pop, it pops what it wants to pop out. Okay, let's see if we pass a value now. Let's see if we pass watermelon to pop it. See, error. Cannot pass what you want to pop. You cannot even pass the index. Let's see if we pass index. Error. So once you do pop takes no argument. See, it takes no argument. Once you do pop, it pops whatever is in his mind out of the. But I think it pops the first element. That's what it does. It pops the first element. Because the way I'm saying it now, lemon is the first one. If I do pop again, see, pop is popping the first element out of a list, out of a set. Okay, that's a good observation. But what if you want to delete a specific stuff? You can also use discard. Discard is the same thing as remove. Look at remove here. It's the same thing. But the difference between discard and remove is that if you use remove, if it does not find the value in a set, it will throw an error. But if you use discard, if it does not find the value in a set, it remains the same. It does not throw you an error. You just move ahead. So okay, I did it here. Look at it. Attempting to discard an element that does not exist, no error is raised. So we want to discard mango. In our list, there's nothing like in our set, there's nothing like mango. You see, no error is raised. But if I want to go and say my var underscore 2 is mainly my var of past Valentine, should be doing my Easter. remove mango now. Mango. So I'm going to get an error. Get it? So that's the difference. There's also one we call the difference between indexing a dictionary and using .get. That's another one. .get doesn't give you an error. So we can clear, and that is all. So once we clear, set is empty. Okay, a set is empty. So somebody will now ask me, so how do we create an empty set? This is how we create an empty set. Let me show you. It just came to my mind. Sorry. Why you cannot create an empty set like this? Empty is equal to this because you feel like this is how you create a set. So if you do something like print type of empty, it just came to my mind, guys. So why you cannot create something like this? This is how you can create an empty set. Do something like this. Empty is equals to the set function. That's what we call set function. If I run it now, see, it's an empty set. So I can now use this value. If I call this empty now, I can use it to do anything I want to do that has to do with the set. See. So guys, sorry, this is the concept to programming. That's how programming can be. It's just to know the tweaks. So why you cannot do this, you can do that. You can also create an empty list or tuple like this. If I do this as a list, see, it becomes an empty list. If I do it as a tuple, it becomes an empty tuple. If I put it as uh, um, a dictionary, it becomes a dictionary. You can if I can do it as an int, it becomes an int. Okay, so it becomes what you're just doing is that you're instantiating this variable to take the properties of these objects. So that's how you can. That's one way you can do empty stuff and be safe with what you are doing. So let's go back to our class. So I think I've taught you guys that one. That was a good one for me to remember because sometimes when you're coding is when I'm in that mood of trying to solve my problems and provide solution. That just remember, oh, I can do this, And guys, it takes practice, a lot of practice and reading. People don't read. I tell you that sometimes I still go to Python websites. I just go to some website. I don't like I'll go to the W3 school. I'll go and look at what they are doing. Sometimes I watch some YouTube video. I just go and watch. The way I am, I watch Pythons for beginners because there is a lot. In fact, now there's this literals, typing script. Python is just improving. So there's a lot to learn. This one I'm even teaching you. There are a lot to these things, Seth. A lot to it that you can learn. So guys, there's no limitation to this. So okay, so let's go ahead. So another thing I want to show you is some method. Let's look at subsets. So I'll just skim this one through. So if we run this, we declared two sets, var1, var2. var1 has a lot of 1, 2, 3, 4, 5. var2 has 3, 4, 5. So we want to check if this is a subset of this. Subset, superset. So, a subset. Someone says I'm going to vary because my head. I was trying to say something to you people. I wanted to say that the mind always feared the unknown. That's why people don't try new things. Your mind is always scared of the unknown. Your mind is always afraid when they see something it does not understand. That's why people think things are difficult. And the moment you begin to think like that, you will never learn. You will never learn. You have that fear. And once you have that fear, you might learn, but you take time to learn. So when you see something that you don't understand, there's this lecturer there in my school that used to say something when we're learning what we call assembly language. Most of you must have heard of that assembly language. So I did computer science in school. So I also met things where we're doing statistics and all of that. When you see theorems that you cannot prove and you see them, and there are some theorems that leads to no answer. It's just to prove to prove. that this is where you can prove to before anybody can come there and prove and go to where they are proving. I don't know what they are proving in life, but it's good. So when we are trying to learn those theorem or those distributions and all of that, the moment you see it at first, your mind is confused. But when you sit down and try to understand what is this theorem trying to prove, or what is this code trying to do. So my lecturer was like I said, we call it moving from the known to the unknown. For you to understand what is unknown, you must first of all try your best to get what is known. Look for that thing that you think you don't understand. Look for what you actually understand inside. If you can get it, you can move. So the same thing applies to a learning code. Look for something you understand. Look from the concept you understand. And it's not more about typing syntax, it's about understanding concept. Okay? If I'm working on project, those are things I do. I'm not concerned about writing code. I want to understand concept first. If I get the concept in my head, the code is just simple. Okay? So I think with this few point of mine, I'm able to acquire to misfire and motive and misfire and everything. So is it a subset of is VAR2 a subset to uh, VAR1? Yes, VAR2 is a subset of VAR1 because if you check VAR2, all the element that we have here is present in set one. So it is a subset. For example, now everything I want to do here, it's mathematics. We learned it in school. Set union, set intersection, set difference. Um, yes, now those three things we learned them in school. Symmetric difference. Um, yeah, we learned all of these things in school. This is just Python doing it, and you can do it with Python code. All these things are mathematical that I want to do now. Subset, superset, all those things were in school now. That was in GSS. I think we did set in JSS two. Those of us in Nigeria, you can find the grade. If you are those of us listening outside Nigeria, there's a grade. So I think they've done it. That should be great. Anyway, that should be great. Okay, primary should be grade six, grade seven, grade. That should be grade eight now. That should be like grade eight because I know nurseries are not counted. So that should be grade eight. So supersets. So look at set union. The same thing. Set union is that the addition of two sets. I want to combine these two sets together. Set one combined by set two. You see, it's combined. But the fact that set does not take duplicates. So if you have any like banana is appearing here, banana is appearing on both sides, we only get one banana because even if you combine the two of them together, it's going to take the duplicates. Set intersection. Set intersection is what is available in set one is available in set two. And we know that it's only banana is available here. Banana and orange. Sorry, orange and banana, the both of them. Let me just highlight them. These two is what is appearing on the set. That's why we have orange and banana. So we can also do set difference. Set difference. So set difference is what is in set one that is not in set two, and what is in set two that is not in set one. So I think I was copy. I don't know why I did my code like this, but it's making me lose context of what I'm explaining. So, but anyways, the idea is we want to say, okay, what is a set one that is not a set two, and what is a set two that is not a set one? That is set symmetric difference. And we also have that's difference rather, not symmetric difference. So we also now have symmetric difference. So symmetric difference actually means, let me see. I think I have to do. I've forgotten this explanation. Sorry. Set one. Let me explain set one. This is set one. Set two. This is set two. Great. So if we say set one dot symmetric difference, we got 478. So okay. So symmetric difference is that we are taking out what is actually extinct between the both of them. So for example, banana is appearing in both of them. Banana is not in our symmetric answer. Orange is appearing in both of the sets. Orange is not in our answer. So that's symmetric difference. Okay. So I think with this, we can do a lot. We can do a lot. You can study more on my val two dots. You can do we've done discard intersection. You can do things like update. We've done pop. I think we've not done intersection of the difference update. We've done clear. We've done copy. We've done remove. So we've not done symmetric difference updates. But this is the basic idea of a set. I didn't want to talk about dictionary, but we still have enough time, so I will just start talking about dictionary. Okay. So a dictionary is a collection of data in key and value pair. So now you see how we declare a dictionary. The way we declare a set now. This is how we declare a dictionary. Okay, with these curly braces. But one thing we say is that a dictionary is a collection of key and value pair. So this is a dictionary. This is a set normally. No, this is a set. It's a set. This is a set. This one is a set. So I just want to show you that this is a set. Okay, but don't confuse it with a dictionary. I'm not going to show you this thing now because this is this way. Yes, let's start from here. Leave this one. Let's start from here. So this is a dictionary. These are a dictionary appears. You can see that the difference between. Just a minute. I need to delete this thing. I need to delete this print I just printed. Good. I want to show you the difference. So this is a set. This is a dictionary. So why I said just have single values inside. A dictionary has key and value. So you see Python, somebody say Python is broad. With this one we are learning. Amen. No, because it is so broad. There's a reason why we say Python is versatile. It is the application of Python self that is even more sweet. So just imagine you know Python. If you know Python, you are good to go. You're good to go. So what's the difference between a set and a dictionary? It's on your screen. Oh, you can see the difference between a set and a dictionary on your screen. So like I'm explaining right now. So you see, this is just single values. But when it comes to a dictionary, you have the name. This is the key, and then this is the value. Okay, this is the value. Now it's more like inside the dictionary. It's like you are declaring a variable and you are giving it a value. But this time you are not putting equal to. You are putting color. Now, can I say something that the key of a Python, the key can be anything. It can be a string, it can be a boolean, it can be numbers, it can be anything, any data type. But traditionally, you rarely see it becoming like that. You occasionally you see it as a string. Okay, but then I want to also state that the value of a key in a dictionary can even be a dictionary, can even be a list, can be a tuple, can be anything. Okay, so just note that for it's very important. So you can see like name is Peter James, age is this 36, marital status is false, course is data analyst, height is 5.5. Now I want to show you something. I've not done this before, but I want to just show you something. So I printed it out. But what if I want to change this. I just noticed something I can use to explain something. So what if the courses, instead of course, we do courses that the guy is doing? I can put a list now and say the guy is also data analyst. The guy is learning graphics and close it here. Do you see that? So I will do this one as info theory for a reason. So I'll run it. So if I come here and print info theory, you can see that in courses, the guy has a list. Oh, sorry, I didn't separate this thing together. Good. I want to separate it together so from each other. So the guy is doing two courses, data analysis and graphics. So they are both inside a a list, a keyword called courses. So let's go back to our previous. What if I want to access? Somebody say, what if I want to access these courses now? So we'll look at that. That's what we are doing. So what if I want to access the item in the dictionary? You don't use, mind you, you don't use the index to access the item in the dictionary. You use the key name to access the item in the dictionary. So that's why you we have something like this. Excuse me. You have something like age, and we put the name of the dictionary. Open that's our index stuff, but this time we'll put the name of a key. So once we do index the age, it will give you 36. You can also change the things inside a dictionary. Okay, so let's say we want to change the name to John Frank, the age to be 30, and the marital status to be single. How do we do it? Just the same way you do in a list, you put the index of what you want to change. This one, you put the key name of what you want to change, and you assign it to a new value. So you can see that we have changed the name, and and then can also change the weight. Now, okay, add a new key. So what this one is that you can see before we did not have weight inside our dictionary. There was nothing like a weight. So in list, if you want to do that, you do dot append to come and add something to it. But in Python dictionary, you can just write the name of the dictionary. What should be the new key that you want it to be that is not in that dictionary, and assign it to a value to it. Once you do that, it will update itself. The new key will come to the dictionary and the value that was given to it. So what about you are trying to get the value of a key that is not present? You will get an error. You try to index a value, you get an error. But if you use what we call dot get, info dot get, okay, to access a value in a dictionary that is not even available, you get nothing. To not give you any error. But you can also get to customize the dot get by putting a message for a user. Hi, can you still see my screen? Let me go to my page. Okay, I guess you guys can still see my screen. So, oops, there's not a dictionary. So I'm trying to look for where to stop, but it seems there's no place to stop. So let's just keep going. So what if I want to get all the keys in a dictionary? I can do info.keys. Now, who can tell me what this thing is? From here, if I mark it from here like this, from this place to this place, what data structure is this? Let me see on the comment section. What data structure is this? A list. Thank you, Docas. Yeah, you're following. But if I map it from here to here, what data structure is this? So if I map it from the way I highlighted it now, what data structure is that? Somebody said dictionary. Yeah, wisdom. Thank you. That's a tuple. Yeah, Francis, well done. It's a tuple. Because if I map it from here to here, but not just as a tuple, it's a tuple containing a list. It's a tuple containing a list. Why this is very important is that so that you know how you can get information that you need. You can get information. So you can extract information that you're looking for when you are working on your code. But anyways, you can look through. You can look through. Remember, we can look through a list, right? So we can also look through a tuple. So for keys in info.keys, we want to print if the key is marital status. We want to. What we are doing is that look through. Maybe we want to search for a key now. We are saying, okay, look through all the keys in the dictionary. If you find any key that is equal to marital status, print it out for us. So if you did not see anything like marital status, nothing was going to be printed out. So it's the same way you can also find all the keys. You can find only just the values in a tuple by using dot values. And please, it's they're all methods, so I'm printing them out so that you can see them. So you see, we can see all the values coming out again. So what if I want to see the items? Like maybe I want to see the keys and the values. You can do dot items. Dot items we map. Now this is where it becomes tricky. What is this? If I call this thing like this, hey, this is where I want to do it. It's not, let me not print it. Let me drop it out single. It's not coming the way I want it to come. Oh my god, it's not coming the way I want it to come out. But I just wanted to see how complex this item is returning. It's returning as something. This is a list because it's from here like this. This is a list down to the end. But this list has what we call tuples. These are tuples. Let me tell you something. You cannot change. You can change, guys. Just practice it. Can you change the value inside this thing? Just imagine if you can change the value inside this thing. So let's say I convert this into a list, which I've done here now. Let me convert it to a list. Okay, so it's not a list. Great. So details is a list. What if I want to say that what is details underscore index zero, for example, is this. If I want to change details zero to who guess now, let's say 0 to 5, will it work? See, it worked. Why is it working? Because even as much as the value inside it is 5, details 0 is a tuple, because this tuple is still appearing on the list, on that list is appearing on that line of a list, you can change the value here normal. But once you index inside this thing, inside this tuple now, you cannot change anything again. So let's work for another one. Let's say -1. -1 will give us the last item. Sorry, will give us the last item. Weight 55. So let's say we now index inside it. So it will be -1 index. Let's say we index weight. Weight is 0. So this is also, we've gotten weight. If I decide to say I want to carry this thing now and say, oh, I want to change this thing for weight to be uh, length, for example. Let's put it as length and run it. See, I'll get an error because I'm accessing inside that tuple, so I cannot change it. This thing is very important. I'm teaching you. So a dictionary also have dot copy. A dictionary also have dot pop. You pop with the key name and it takes it out. You can also copy with a dictionary. We've seen dot pop just now. You can also do there. Remember there that we did on a list. You can also do there with a dictionary. Then you can also do clear in a dictionary. And the next thing I would have thought, let's see, we can do dictionary comprehension. Wow, this is good. We're almost done with dictionary already. Okay. So we say as if the tuple itself is a value, but you cannot change it when it's inside the tuple. Yes, Francis, you're right. So this is um, dictionary comprehension. Remember list comprehension that we did the other time? Yes, you can do dictionary comprehension. So you can, this is a dictionary that we have. D is equals to, you see, A is 1, B is 2, C is 3, D is 4, E is 5. So this is a simple dictionary. And we can look through, remember, we can look through it. And if we want to look through with dot items, what we are getting is the key and the value. So we can run it like this. It will give us the key and the value, and they are returning as a tuple. What if we want to create a new dictionary? So creating a new dictionary with only pairs where the value is greater than 2. So we will do something like this. We'll say that new dictionary is equals to We'll open our dictionary symbol. We'll put the key. The key is K. The value is V. This is the value that we want to save. Remember our list comprehension. Then we'll now run our loop. So for K in V, because dot items is giving us two things, is returning one and two. So we need to say we need to do two temporary variables that fetches the item is bringing out. So, but we will not do our condition. Our condition is we want to check if the value that you are bringing is greater than 2. So if the value you are bringing is greater than 2, save the key and the pair into a new dictionary. So by the time I run this, by the time we print a new dictionary, voila, we've been able to create a dictionary in one line. Can we do this in a multiple line? Yes, with a for loop, we can do that. Can do that. That will be an assignment anyway. Or let me just do it. So I can say for k comma v in d dot items, right? Then I'll create an empty. So I'll say new underscore date is equal to is empty. And the next thing I'll do, I'll say if v is greater than 2, the next thing I want to do is that I want to say our new dot item dictionary dot k is equal to our v. This is it. So I will run this code. By the time I come back here and print new dot v, you see that voila, I got the same answer that I got here. I got the same answer that I got here. So they are both the same. So you see this line of code I just did, it can be written in one line, and that's what we call it a comprehension. So this is just another way of doing list comprehension. It's another way of doing list comprehension. Okay, I don't need to talk about that. I want to talk about how to convert data structure. How to convert data structures. To convert data structure, let's say you have a list, you want to convert it to a set. If you want to convert a list to a set, you just use the set function. So this is a list we created into a variable called new list. Call the set function and pass the list inside. It will convert it to a set. And notice that when you converted it to a set, it will remove all the duplicate that you have previously in a list. Same way you can convert a tuple, you can convert a list to a tuple, and you can run all of these things vice versa. Okay, you can convert a tuple to a list, a tuple to a set. But please, you cannot do any of them to a dictionary because a dictionary comes with key, value, and pair. So this is a set that has fruits. If you can convert it to a list, the fruit to a list, is it? You've converted it. Now that you've converted it, it will now take the properties of a list. And you can convert a set to what? A tuple. This is a tuple of fruits, but we can convert it again to a list that will allow us change, and we can convert it to a set. Ladies and gentlemen, with this viewpoint of mine, we've come to the end of data structures in Python. And that means that we are moving at a very, very light speed. So there's a lot to what you can learn. Please learn, practice, use them, watch these videos over and over again. Spend your time on these videos, and yeah, you'll be good. So tomorrow we'll pick up from another topic, and that will be awesome. So the assignment for week one closes today. Immediately after this class, I'm going to close that link so we can prepare for assessment for week two. But I will not give you any assignment now. I'll just tell you, please come and watch this video again and again and create your implementations. If you have any errors, screenshot it, send it to the Slack channel. Tag me, tag Grace, tag anybody. Disturb so that everybody can say, hey, please, what is this? But I know sometimes some of the questions you want to ask, if you go back to my video and watch, you understand it better. I know. I know that's why most of you are not asking anything on the group because everything we are doing online is crystal, it's just clear. So it's clear for you. So I understand. That's why most people don't shout on the. Even when people were talking about, I don't understand this. I who saw Grace tell the person, go and watch this video. If you watch this video, you understand better. So every of the video I do, I ensure that they're very, very clean and and good for you guys. So we'll meet at our gossip end, which is the Slack channel. Till then, guys, keep practicing, keep doing great, and thank you for always turning up and coming to class. I so much appreciate. Okay, so bye bye, guys.